we mentioned if we have the theta rate, and then we can quantify the flow conditions is rotational or not rotational. But the key concept in here, before we quantify the theta rate, we need to know the theta A and theta B, the rate from the theta A and the theta B, and we sum of the theta A and theta B, and divided 2 is equal to the theta rate. So the key points in here, we need to know how to calculate the theta A rate and the theta B rate. Okay, and then we can check if the theta rate is equal to 0, and then we call that flow is irrotational flow. Okay, so the next slide, we have two status. The first, we are looking for the fluid particle and the fluid particle at the different time point. So this is time t, and this is time plus delta t. So they are in the different time status. And before, at the time t, we have the 3 important points. The 0 in here, and the 1 in here, and there is the 2. Okay? And delta t later, the 0 move to the 0 prime in here, and the 1 move to the 1 prime in here, and the 2 move to the 2 prime in here. Okay? So clearly we observe only delta t time difference, and then the points move at the different locations. And if you take a look, the angle in here, we call that is the delta theta A in here. And the angle in here, we call that is minus delta theta B. So why? The reason there is a minus. Okay? As you can see, for this delta theta A, the theta change is along these directions, right? And this direction, if you cross by your right hand, it's positive directions, because the rotate is clockwise angle, right? So use the right hand side, your right hand to cross. But in this delta theta B, the rotate angle is these directions. It's clockwise, not counterclockwise. So if in this direction, if clockwise, so the direction is inside the papers. Okay, so that's why there is a positive angle and there is the minus, because the direction is different, and you can check by your right hand cross. Okay, the theta A is counterclockwise rotate, and the theta B is clockwise rotate. So they are the sign is different. One is positive, another is negative. So the key question is, if we can identify the theta A and the theta B, if we can identify the theta A and the theta B, and we know exactly the time difference is delta t, so we can divide the delta t and divide the delta t. So we have the theta A rate and the theta B rate, and we define the theta rate is equal to 2/1 theta A rate plus theta B rate, right? So the key in here, we need to know what is the delta A, theta A, and what is the delta theta B, and then we can compute the rate of the theta A angle and the theta B angle. So in here, if we fix, we observe the 0 point and 1 point here, and we know from 0 to 1, the length is delta x. The length is delta x. If we take a look, the 0 prime to 1 prime, this bar, the length still delta x, because we just rotate the bar, so the length didn't change it. Even though you rotate the 0 to 1 to the 0 prime to 1 prime, but this length didn't change, so still the delta x. If you know the length in here is delta x, and you see here we have the delta y1. We have the delta y1 is the length, is the height in here. So we know that the relationship between the theta A, delta x, and the delta y is sine delta theta A is equal to delta x over delta y1, right? Because this is sine theta is equal to delta x over delta y1 in here. And then if we know the delta, can we compute the delta y1? If we can compute the delta y1, and then we can know the sine theta A. What is the sine theta A? So if you take a look, so the key is in here. We need to define the delta y1. So this is the 0 point, and then we know the velocity along y directions. Along the y direction is v at the 0 point. And if this is the point for 1, and we assume from the 0 to 1, the velocity v change with the x location is linear. So if we from 0 to 1, the velocity along the y direction is changed to the v plus dv dx multiply delta x. We apply the Taylor explanations, so we know we assume the velocity changes along the y directions for the v velocity is linear changes, and we know we have the delta x spatial changes. So in case the velocity at the 1 point can be represented, follow this formula in here. Okay, so 0 is v velocity along the y directions, but the point 1 is v plus delta v delta x multiply delta x. So in that way, we know the length, because we know only delta t time difference. So delta y1 can be equal to the velocity at the point 1, v plus delta v dv dx delta x, and plus multiply delta t. This is the velocity, and we have the delta t time difference. So this is the length, the travel time length. This is the flow velocity, and we travel delta t time. So this is the travel length at this location. And if this length minus this length is the v travel with the delta t time. So we have the v delta t length, and this is equal to delta y1. Okay, so if you take a look, v multiplied delta t minus v multiplied delta t will cancel out. So in that way, we only have the dv dx delta x multiplied delta t. This is for the delta y1. This is for the delta y1. So we put these answers, go back to here. So delta y1 divided the delta x. So in that way, the delta x will also cancel out. So here we only have the dv dx multiplied delta t. Okay. So, but as I mentioned, the second assumption in here, usually we know that if theta is small, why the theta is small? Because the delta t is small, only small time difference, so the rotate angle should be small also. So if theta is really small, that means the theta close to 0, and then the sine theta will equal to theta. Okay, this is when we have the mathematical class, we know that the relations. Okay, if theta is quite smaller, the sine theta is equal to theta. So in that way, we know because the theta is quite smaller, so this is equal to theta A. Okay, so we follow this equation, we know finally we can summarize the theta, delta theta A is equal to dv dx delta t. But our key question is we need to know the theta A rate. We need to know the theta A rate. So we will compute, follow this equation formula showing here. So we know the theta A rate should be equal to the dv dx, because we cancel out the delta t here, divided the delta t. Okay, so this is, first we know theta A rate in here. So again, what is the theta B rate? So if we take a look in here, the only difference is for the theta B in here. So we know the sine delta theta B also can be represented by the delta y. The length from the 0 prong to 2 prong is delta y. So we have the delta y over delta x2 is equal to the sine delta theta b in here. Okay, so the key in here is we need to compute the delta x2, and then we know the delta theta b. And then we directly know, because the theta b is still small enough, so finally this is will equal to delta theta b. So for these equations, we need to calculate the delta x2 first, and then we know what is the delta theta b. So again, we have the 0 in here. We have the 0 point in here. And we know the velocity along the x direction is u. But if we change the point to 2, so now we change the point to 2, and then the velocity along the x direction will change to u plus du. We assume the velocity along the x direction change with the y. Okay, is linear. So we still have these equations, du dy, and then multiply delta y difference. Multiply delta y difference. Because the points start from 0 to 2 points, there are the delta y location difference. Okay, so again, so we know delta x2 should be equal to the u plus du dy delta y multiply delta t minus u multiply delta t. Okay? So again, so we cancel out the u delta t minus u delta t. So in that equation, we only have the du dy and the delta y. And then we still have the outside delta t. Okay? So here is delta t. So we take a look, summarize the delta theta b is equal to delta x2 divided delta y. So we cancel out here, the delta y will cancel out. So finally, we only have the du dy delta t. And then follow this equation showing here, we know the theta b rate is equal to delta theta b. But as I mentioned, the theta b angle is rotate angle is clockwise, so we have the minus in here. So we need to have the minus and divided the delta t. So this is the positive delta theta b. So we need to have the additional minus sign in here and follow this equation divided delta t. So delta t will disappear. So finally, we only have a du dy minus du dy. Okay, this is for the theta b rate. And here, where we have the theta a rate. And then you push to answer back to this formula in here. So finally, we know the theta rate is equal to 2/1 theta a rate in here, du dv dx, and the theta b rate in here minus du dy minus du dy. Okay, so so we know the final formula, the theta rate in this example can be represented by this formula. So the physical meaning in here is velocity v change with the x directions minus velocity u change with the y directions, and the half of the answers, so it's equal to the theta rate. And this is the rotation angle rate is with the rotation axis is along the z directions for this example. So in real case, we can have the different rotate angles. We have the different formula, right? So the next slide, we summarize. This is the first derived from the previous slide. We have the rotate angle along the z directions. But the following, we have the rotation angle along x and the rotation axis along the y directions. So we have a different formula. So if you compare each other, you know, if I have the velocity field, this is for the u in x directions, and we have the v along the z directions, and we have the w along the z directions, I, j, k, x, y, z, u, v, w velocity. So we compute the outer integrations. So if we do that curve, so you know we put the I, j, k, and we have the differential operator dx and dy and the dz, and we have the u, v, W, okay? And you try to calculate these outer integrations. So we have the I directions, and we have the dW dy minus dV dz. So we have dV dz. And as you see, this is I component. So the rotate axis is along the x directions. If you compare the left-hand side showing here, they are the same, right? They are the same. Only difference is half constant value in here. Okay? And then if you check the z directions, so that means the rotate angle is axis is along the y directions. So you see, if we do the outer integration for this part, this is the du dz minus dw dx. Okay? And if you check the k directions, so we have the k directions, so it's equal to dv dx minus du dy. Okay? So actually the theta rate will equal to the gradient operator's outer integration with the velocity factors. And then we have the 2/1, right? And we have additional 2/1s. So that means if you do curl operators, and you can check this is if equal to 0, that means the flow is not rotational flow. So you can simply compute this. So if we have the mathematical operator like this formula, that will help us to check the flow condition is rotational or not directly. So if not equal to 0, that means the flow condition is rotational flow. Okay, and usually we will say that ideal flow is meaning the flow is irrotational and incompressible fluid. Okay, if your flow satisfies two conditions, we call that is ideal flow. And then usually the flow field in which the viscous effects are small. And then we can say that the flow is irrotational flow. So in other words, if the viscous effect is large, so usually the flow is rotational flow. Okay, so I check the time, so we still have the time. So, and then following these equations, formulas, so we define one parameter, we call that is the vorticity, Wo. Okay, so usually you just simply multiply two times to cancel out the 2/1. Okay, so this is usually we use the omega indicate the vorticity. It's very important parameters. And then you see that this is very important if the flow is rotational flow. We need to take the viscosity should be taken into account. Okay, the viscosity should be taken into account if the flow is rotational flow. Okay, this is very important effect if the flow is rotational flow. Okay, so we very quickly to do the one exercise. If I provide you, this is our flow field. So based on these velocity factors, we know that the U is equal to 10x, right? And the V is minus 10y. And we don't have the W because this factor there is no K components. So our question is require you answer is the flow irrotational or not. Okay, so first you need to check if we do the curl of the velocity factor is equal to 0, that means the flow is not rotational, right? So we just compute this formula and check 0 or not. So very quickly you can compute that the answers. We have the I, J, K, and the dx, dy, dz, right? And then we have the u, v, w, and then you can compute that. So for my personal opinion, we don't need to compute, because if you take a look, usually what do we have? If we focus the I component, and then we have the dw dy minus dv dz. If you take a look, the v velocity is not the function with the z, only with the function with the y directions. So in that way, we don't have these components, and we don't have the omega velocity. So this is a component we don't have. So finally, this I component is equal to 0. And then we check the j component. The j component is du dz minus dw dx. And then again, we don't have the omega w velocity, and the u is only the function changed with the x, didn't change with the z. So we don't have these differential values, also equal to 0. Okay? So finally, you can check the k components. The k component is dw, dv dx minus du dy. So again, v only the function as a function of the y, and the u only a function of the x. So you don't have the differential values, also 0. So finally, we know exactly the answer is 0. So we can conclude that the flow is irrotational flow, because the final answer is 0. If not equal to 0, we will say that the flow is rotational flow. Oh, okay, so it's a quite simple idea. We just simply calculate these operators with the gradient operator with the flow velocity factors, and then check is 0 or not, and then you can conclude that the flow conditions. And the physical, the key knowledge is if the flow is rotational flow, so the viscosity effect is very important. If you check the flow is irrotational flow, so we can ignore the viscosity effect. Okay, so it's a basic ideas for we check the rotational or not. Okay, so we start here.